Welcome back to Stationeers. Today will be entirely about programming, and I hope I'll be able to convey the most basic concepts, because it's hard for me to imagine what that's like to not know anything about it. I've been doing it for so long. But that's the same with anything that anyone explains to anyone else, you know. You have to understand they are seeing all the trees around them, while you have climbed above and you are seeing the forest. For you it's completely normal. And that is how basically all things in life work. You can look at all the data points of the set, and then you suddenly grasp the set. And that's actually very interesting. If you look, for example, at Newton, he saw things fall and thought about how that works, came up with some concepts, and he made some good answers. Then Einstein came along and realized the set that he found that comprises all these data points is actually not complete. I found some data points, for example, the path of Mercury around the Sun, that don't fit in that, and so he came up with relativity, and well, that has to be surpassed still, and hasn't been yet. So that seems to be the set that contains all of those data points. So basically with that, we're looking at things in reality, then we're understanding how that works, and then we're climbing higher and higher. We're understanding more and more greater concepts, and I think it's very interesting to think that every data point that we look at isn't really a thing. It is already a set. And then we climb higher and find the set that comprises them. That is again a data point of a larger set. And then we climb higher and higher, and what mankind is trying to do, obviously, is to try to understand what makes the universe tick. You know, what's the highest concept that encompasses all of them. But what's more interesting right now is that when you do a project, when you want to develop some software, when you build a house, a station, you do the opposite. You're not climbing up from the data points. You are defining the foundation, and then you're climbing down into this set, into this system. If you look at reality and climb up by looking at the data points and find abstractions, like I'm seeing lots of cars, and then finally I kind of know what a car is. So if I see a data point that's not of the set, is not among them that I have already seen, then I will still know it's a car. See, that's what I mean by abstraction, by finding the set. So if you climb higher and find higher and higher data points, it's like a pyramid, until we find the highest data point that contains all of it. And that of course contains the big question, is there a God and all that stuff. But when we do a project, we're doing the opposite. We're starting at the tip of the pyramid, we're making a decision, and then we're climbing down, and we are defining those data points. But is that really what we're doing? The data points are a consequence of our decision. They are already there. Only, like, to make them happen here in reality, to build something, to program something, to build a station, we have to really make them happen. But they are kind of already defined. I mean, roughly at least. That's why it's very important to make the right decisions when we go into a project. The top level has to be the right decision, then the levels below that, the next data points have to be the right decision, because everything follows from there. Anyone who has ever developed software, especially for a company, when they say, hey, we want this and this, and then he did what they wanted, then it turns out they were not so aware what consequences in the lower levels their high level decision would have. Because then they start trying to morph this thing around and change it, and then you realize you're the one who has to make that happen, and thus has the mind to understand this hierarchy, or at least to deal with it. We'll see these higher levels also have to be changed. We can't just change stuff around down here. The whole thing, we have to go a few steps back, basically. Okay, so let's look at some stuff here. Here's my stack of station batteries, forgive me. These are not the large ones. This is one of my first stations. And what I'm showing up here is at the top. Can I see that? Yeah. Is the level of my station, how much energy do I have, and these LED displays have 3 modes. This is mode 1, which just shows a number. Mode 2, actually mode 0 is this. Mode 1 is the one that shows just a percentage. Yeah, with a percentage sign, I think, too. And mode 3 shows kilowatts or watts or whatever. This the unit will change according to the scale of the number. So why am I not showing a percentage here? I mean, what I'm showing here is how full my station batteries are, and I'm showing a number from 0 to 10,000. Why the fuck would I do that? Well, if I show a percentage, then I will only have, like, I think one decimal place, or not even one, I'm not sure. But I want it more precise. And if you look at this, this would be 84%, 84.78. Why then am I not just using 0. Like here, for example, this is the CO2 ratio in my station, 0.48, that's 84%. Why am I not doing this here? Because let's say we have a current value of 0.50000, like exactly 50%. Then this display would only show 0.5 instead of all the other zeros. But the number will be centered horizontally. So depending on what the decimal places are, the number will be jumping around. I didn't want that, and so I just eliminated the decimal places by multiplying that whole thing. And then rounding it to full integer. Yeah, those are tricks that you can do, and I did that with the IC10, because then you don't have to put up like 10,500 chips to make that happen. It's only one chip. This one. Actually, not this one, it's over there. Doesn't matter. Oh, let's take a look at this. Also something you can do. Here is a chart display, and now the sun is coming up. That's fortunate. Good timing. Because then you can see the temperature is rising more quickly. This is also not showing actual degrees Celsius. What happened there? Well, my cooling kicked in, and now it stopped. Now the temperature is rising again. So this chart display is a bit sucky. I hope they will change that. Rocketworks, you know. Because it always starts at 0, except if you also have negative values. But if you have positive values, it always starts at 0, and then it goes up to the maximum that the current chart will show, you know, the current chart. And this shows a stretch of 30 seconds. You cannot alter that. So if, for example, the highest value is 23 degrees, which is what I'm gunning for here, and we start at 0, then the very slight fluctuations that are actually happening here will not be visible. But I just you know, use multiplication and stuff, just like with my station battery ratio display, to use a different value. I mean, it looks a bit stupid. Here we have a 10,000 instead of 23, blah blah blah, but I'm living within the bounds of what is available to me. And here I can then nicely see, yeah, what's happening. I think this is a really nice display. Should kick in now again. And here we go. There's automation. Yeah, we started as cavemen, or should I say cave people? Well, I don't care. We were bashing rocks together or against people's heads if they were not winning. And then we got tools, and then we had machines like the steam engine, and then we had cars, and then we had cranes where a little 1.4 kilogram organ can control a 10,000 ton fucking crane. I mean, imagine what that is. That is mind over matter, only, you know, within the rule set of the universe. I mean, I don't want to go spiritual here, but that's what that is. That's mind over matter. And that's what mankind has been striving for, you know? Like, basically, let fantasy become reality. Isn't that kind of the goal here? We want our fantasy to be reality. And that's what mankind has been doing for thousands of years, to make that happen more and more. And I mean, basically, today a mind can reach much further into the world via the internet, via calling someone, whatever. And this means that we are affecting each other more intensely than before. And since that is so, your life is being affected by someone else's mind. I wouldn't say directly, I don't want to go there, that's not what I'm trying to say. What I'm saying is, if another person's mind affects your life more than it did before, then this also means your mind is affecting them more, and this also means that this feeds back into our minds. This is why basically we all have to improve, we have to perfect ourselves. That's the only way to coexist. I mean, the world is becoming more and more our fantasy playground, and this means that our minds must more and more be capable to handle that power. That is what this is about. But okay, let's return to the topic of programming, which is along those lines, because then we are telling reality what to do. I'm programming this machine, and then a piece of reality, I mean, it's just a game here, but in the actual physical reality that's happening too. You're telling your washer to turn on before you get home. Then you get home and your cleaning will have been done already. For example, we're achieving non-locality and we're achieving mind over matter. That's what's going on here. I wouldn't call it the apocalypse, but maybe that's even what it is. Anyway, now back to programming. Here we have my stack of batteries, and here we have the chip that makes sure that we get this value on here and multiplies that. But back then I didn't know too much about this stuff, and so to obtain the average ratio here of the batteries, I'm using a logic chip. I dealt with these in the previous video about greenhouse and chickens and such. This is a batch reader. Okay, there's the reader chip. This is a batch reader. There's a reader chip that can adjust from which device it will read and what variable it will read. And I could basically turn this knob with a screwdriver, and then I would hit this, that, or whatever battery, and that would then be the device from which this chip reads. Then I could define I wanted the ratio, and then I would have of that battery a value from 0 to 1. Values from 0 to 1 are very useful for programmers. You might think that the station battery would have a charge ratio from 0 to 100, like percent, or from 0 to 10. But that's not so useful for math, you know. Okay, I'm going off topic. So you would read the value, and then you would have the ratio. But this chip has another screw which also tells the chip what to do with all those values, because it's a batch reader. It doesn't read just from one device. It reads from a device type, and the device type is this battery. So it reads from all the batteries simultaneously. It has like, I think 40 or so values within it now. And what does it do with that? It averages them. See, that's what it does. And then I get the average charge, and then it's up there. If I would also have some large station batteries, then I would have to have another batch reader that reads from those. Then I would have two average values, and then I would have to average those again. I think that can actually be done with another batch reader which reads from batch readers, so that could be tricky to wire up. But that's not our problem, because we can just do it all with this chip here. So let's do some destructive stuff and remove that chip. Now we no longer get the update there, and this thing is flashing an error. Why is it flashing an error? How does it know that that chip is gone now? Well, if you watched my previous videos, you will have seen, which you don't need for this one, then you will have seen that I never used these screws around here. Instead, I was just screwing around in the source code. These screws allow you to assign up to 6 devices, and if you look here, you can see batch station batteries average ratio. That is the name that this chip had, this batch reader. And so when I turn the screw here, then eventually I will arrive at that chip, and this means that the slot, the input D0 will have that value, you know, that average. And then I can go into the source code and can say, take the value of D0 and do some math stuff with it, and then write that new mathematically altered value up there to that LED. I often say LCD, that's a mistake, sorry. LED display, liquid crystal emitting diode, I think something like that. Okay, now it doesn't have this input. So let's take our trusty laptop somehow. Damn it, dude. Unfold, I need you. Put the chip in. Make sure you click the import button, else I will overwrite what's on the chip. I don't want that. And then edit this. Let's not go into all the things here. But let's go to that one thing that I just talked about. This line... okay, where should we go now exactly? Okay, I will first be a bit coarse. I will not go into all the details. This line reads the value from D0. into register R0. But what I will do now is I will instead read directly from the battery. I will explain that afterwards. You don't have to understand all this code now. It looks like it's a lot, but there are some more things going on. I'm setting the color of the LED depending on how full the batteries are, and I'm writing the value to the LED, but that's not relevant for us now. What we want is we want to replace that stupid logic chip with code, because then you're not dependent on those screws, and then you will not be screwed if you rewire something, because later you can just put up the device again, give it the right name, and your source code will work, because the screws, they would be referring to the exact device. But once you have unbuilt it and rebuilt it again, it is not longer that exact device. It's a new device. The old device is gone for good, and so the screw, its setting, will no longer work. But if you address the device by its type and name, then you just have to have a device of that type and of that name in the same cable network, and then you'll be fine. But as a cable network, I'm not going to go into cable networks this time. I hope I explained that at some point with transformers and the fuses and all that stuff and cable load. But this time not. Well, let's just assume there are cables everywhere and the chip can see all the devices that are connected. However, you can separate the cable networks so that you can have some devices here, and in here we have other devices. That's all. I'm not going to go into that further now. So let's do some definition. I will explain this. So put the chip here, export, and look at the thing here. Now it's green again. And do we see that change? Yes, we see that change. So what we just did, very conveniently, we rewrote 2 lines of code, and we replaced this entire logic chip. And also the hassle of having these screws. That's very convenient. So that's something we want to learn, yes? Okay, let's go in here and do that. Okay, programming. We are telling the computer what to do, and the computer is very stupid. It's a matter of context. You know, when you are at home with your family and telling them stuff, then you will have the same context. You will know we're sitting here together, you will know each other, you will know the things on the table, and so if someone says something that is very blurrily defined, only very circumstantial, they will still know what you mean. But if you, for example, are in an office context at work and you say something, someone else might not know exactly what you mean. What customer are you talking about? Are you talking about this software or that? Are you talking about today or yesterday? And so forth. That is all the context, you know, the context is necessary. And the computer doesn't have any context, so you have to explain everything to it from the ground up. So let's do that then. Let me first give a short summary of what this source code is doing. It is obtaining the value of the average ratio of the station batteries. It is scaling that mathematically, and then it is defining a color for the LED depending on how full the batteries are. Then it is writing that color to the device. That's also writing the value to the device, you know, how full the batteries are. And it's also writing the mode to the device, you know, number versus percentage versus wattage. And yeah, that's what it does. Now let's explain what exactly this code is doing. Up here you see definitions, and here we see start. The word start is a word that I made up. I could have written anything here as long as it doesn't have any characters that are illegal. Oh, you can even use digit at the start. That's actually uncommon. So this is a marker. And down here we have the command J, which means jump. You can actually hover with the mouse and then you see what it does. Jump to start. So what we have here is an infinite loop. Is it infinite? I actually can't tell, because somewhere in here might be a statement that jumps somewhere else and then we will be outside the loop. But okay, that's off topic. Here we have start, and then we jump back to the start. And that is what this code does. As soon as the chip runs, it executes that stuff over here, it arrives here, does all that stuff, arrives here, and then goes back to here. So this is happening again and again. Now let's see what the machine is being told to do. First, something circumstantial, not so important right now, but fundamentally important for the programming in this game, the yield statement. This game does a lot of simulation, and so you have to be lenient. You cannot expect everything to run at light speed. The program will execute at some sufficiently fast speed, but you can't expect it to be like burning your processor all the time. It has to take a break, so the game simulation will not be overburdened by it, and so the simulation will force your program to take a short break every once in a while. I think every 120 lines of actually executed code. So what most of us MIPS programmers do is when we have our start marker, to which we often then jump back, because most codes actually have some kind of main loop like this. The first thing we do is we yield. That is what the game simulation will force this program to do anyway. So I do yield myself, so the game simulation will not force it. So I have it here in this defined space. So I know the rhythm and everything, it will be reliable behavior and so forth. I would just have start and yield. So you don't have to understand that really. Just write start, yield, and then jump start. And then you will have a nice main loop in which you can continually do stuff. So what is it that I do here in the first line? I'm writing... Okay. First, let's talk about the S and L statements. Here you see SB, but this is S. Is that different? Yes, it is different, but it's only a different variation. We have S commands like SB, and we have L commands like LB, or LBN, like load batch named. But fundamentally you have to understand S and L. I will go into that further. And then we have the branch command, which allows us to jump to places conditionally. This is an unconditional jump. It just jumps to start. But we also have conditional jumps, like for example, branch if something is greater than or equal. And the thing that I want to check is, for example, in register R0, and the value with which I want to compare it is, for example, 0. So if the value is greater than or equal to 0, jump to, let's say start, for example. That's what this does. And there are many variations of this. This is greater than or equal. This is greater than. This is less than. Less than or equal. You can look up all that up here. Actually, it's currently most prudent to look that up in the MIPS documentation page of the unofficial Stationeers wiki. So all you have to do is Google for Stationeers MIPS as one word, MIPS MIPS, and then you will find that page most certainly. Here we can see lots of stuff. For example, branch if greater than or equal, and then we see this. You shouldn't press enter here to confirm your search, because that will stupidly input something into the source code. That's a bit annoying. Certainly something that will fix eventually. It's early access. You have to understand this game, even though it is already better than all the games in existence by a long shot, it is still in early access, and so you have to live with stuff, okay? For example, that the tutorials are currently not working, but the developers are working on that actually as we speak, even though the holidays aren't even over, and they will make sure that this works. Otherwise, you can roll back to an earlier version of the game, which is very easy with Steam and also quick, and then you can play the tutorials, the pre-phase change version. Then you can play the tutorials, and they can return to the normal version and then play with all the knowledge that you gathered. So here we see the functions and the documentation, but you can also just hover here and then you will see the same documentation. So let's look here for the J command. It will say jump execution to line A. That's interesting. Line A? It's as if it's expecting a number here, and that's what it's indeed doing, because what's written here is not start. From the computer perspective, what's written here is, what's up here? 8. It's as if I put the number 8 here, but obviously I won't be doing that if I have a feature like just a label there, because as soon as I do this, my source code won't, actually it will work. It will jump here, but for example, yeah, you know what I mean. You know, it will jump to the wrong line. If you do this, however, it will jump to the line wherever start is. And there's another situation where you might be where you actually want to jump according to line numbers, and that is when you want to branch relative. Branch relative greater than R0, 10. So if the register R0, one word on register, there's register R0, R1 up to R15. That's 16 registers that you can use, and the register is just a value holder. You know, when you write something on a sheet of paper, like a 15, then the sheet of paper is your register, and the number 15 is stored in it. A register can only hold numbers, but it can also hold some meta information, that is information about the information that it is holding, and that can be, for example, NaN, that is short for not a number. When you, for example, have do divide into register R0, 5, 0, then I'm dividing 5 by 0, and you know that division by 0 is not defined, so the outcome will be not a number, and so R0 will now hold NaN. I know it's a lot of stuff, but I'm just trying to give you some broad overview. Basically what we're doing right now is we're looking at data points. I'm giving you lots of little data points. You're standing in the forest, you're looking at the trees, but later you will see the forest from above, and then all these little data points I'm currently throwing at you will be telling you a lot of things. So let's branch relative. Branch relative greater than if register R0 is greater than register R1, for example, and then it wants to know where I want to branch. So what's happening here? If the register R0 is greater than the register R1, the number within, you know, then it will jump one line forward, which is completely stupid to do, because if the statement will not be fulfilled, it will execute just the next line instead of branching. But if I do this, then this means I would skip this line. Honestly, I don't know what happens here. My assumption is that the execution will indeed just go here, will realize, oh, there's nothing written, so we'll just move on to that line. I assume it will not throw an error. If it throws an error, then you will see that little LED flashing orange, and it will also tell you what line the error, where the error is. It will probably then tell you line 12 has an error, and then you read this and then you wonder, there's nothing wrong here, it's jumping here, that line exists. But there's nothing in that line. I'm not sure if there will be an error. I think there will not be. Here you have a relative branch, and you can see that this is a nice thing to do. Why is that a nice thing to do? Because the alternative would be to branch absolutely to a label or to a line number, but we have learned that's a stupid thing to do. Then you would have to have that here instead of just, you know, the next thing that you could execute, you know. So that is why branch relative can be a very nice thing to do. So let's look at what the code is doing. Let's ignore this, which I put up just now, but at the old stuff. Here I had defined something about the arc furnace, and down here I'm doing something with the arc furnace. What is it that I'm doing? You know, the S and L statement, they load and they save a value. Here I'm saving a value with B, which means batch, you know, just like the batch writer chip. We had a batch reader chip, but the batch writer chip just does the opposite. You can write to all the devices of that type. And that's what I'm doing with this statement. I'm writing batch, meaning to all, of the arc furnace. But what is this here, this word? What is that? That's a number. So why does the computer then know what to do? Because the program, the game, has things within it that can potentially exist, like batteries and the arc furnace, and they have a very specific number that we don't have to know, but we can look that up. Actually, let's do that for one. Press F1, you know, up there, F1, the Stationpedia, and look for the arc furnace. Here we have the arc furnace, not to be confused with the kit arc furnace. If I click here, I get the kit and how it is to be produced. And here I get the arc furnace itself, or any other things that might be built with that kit. And here we have some description, how much power it uses as per default. And we also see down here the logic values that it has. For example, it has the activate value, which is the little button that you can push to get that thing going. And up here we see the hash. This is the number that is in my source code without you actually being able to see that number, because instead of the number I'm using this text. But the computer, the source code, it doesn't deal with text. Here, that's the thing. And if let me first show you why I would go through the trouble of programming something with the arc furnace. I mean, you know the arc furnace, right? You toss something in, you turn it on, you push the button, it will smelt that, it will come out here, you toss in the next thing, and then you push the button again. Or you use your autolathe, even the basic one, to dude, did that work? You do use the autolathe to produce some chutes, and then you can have this nice stack here, and everything that you put in here will be waiting for you to smelt it. But here I'm not waiting. I don't have to push this button for everything that has to go in. The button is being pushed automatically. And that is what that line of code does. So you can see it's quite a desirable thing to be able to do, so I'm teaching you now how to do that. So you put some chutes on there, you would be able to do that yourself, but the programming is here. So, the computer doesn't understand the name... Sorry. The computer doesn't understand the name arc furnace, but it can address the device type arc furnace when you give it this number of the device type. And up here I'm defining a word that I made up. This is just a word that I can find, could as well be this word. And I'm putting this number into this word. I'm defining a word, and this word shall have a value, and the value shall be the number of the station battery. You saw in the Stationpedia that we have this word there, and if you click that word in the Stationpedia, except if it has these 3 dots because the word was too long to be shown in the Stationpedia, then that sadly doesn't yet work. Then the word will be copied to the clipboard. Then I can paste it here. But it's very, very easy. You can remember that you just have to first type structure with an uppercase S, and then battery. And for the large batteries, it's large. And for the active vent, it's structure active vent. And for the gas sensor, it's structure gas sensor. So instead of looking up those numbers and copying them in here, which you can do, you know, instead of doing this hash thing, I could just copy the number that I saw in there and paste it here. Instead of doing that, I will not just open the Stationpedia every time. By the way, we can pause the reality simulation up here. That's useful because programming might take some time, and meanwhile your hunger meter ticks down and your station might explode. Instead of looking that up all the time, I just remember this concept, which is very simple, and then I just have this number in here. And what do I do then with this number? Down here in our main loop, so this is happening again and again, right, which you can see by the glowing that piped up again and again when we're standing at the arc furnace. It is doing again and again the following. It is writing to device, it's writing to device, all of them of the type. This is the type, you know, up there, the number. And then I'm saying what I want to change of this device is its activate property. And what I want to do with that, I want to say activate 1. Let's say this would be a door. This would then be the open word. I would have open here. Okay, let's just do that. SB CLS my doors. Oh. Sorry, I have to deal with stuff. Oh, just a moment. Oh, that's interesting. I can't type while the editor is open. I hope that will now stay away. So I have my doors. I write to all my doors open 1. This means the doors will now open. And this will close the doors. Isn't that cool? And you can also say lock 1, which means that I can no longer operate the door. So if it's open or if it's closed, if I push the button, nothing will happen. I can, of course, use the MIPS programming to react to me trying to press the door button in vain, which is something we will do later in this video when we will program our AIRLOCK. Okay, but let's go further. This is the write batch command, and there's also a load batch command. But there's also the write batch named command. What does this mean? This means that I will write to all the devices of this type, of this name, and then I can do this stuff like open and 1. So if I want to address a specific device in this code, I can do write to all of the devices that have this name. And when I say all of the devices, I of course mean all of the devices on this cable network. Write to all devices of this type with this name that they shall open 1. How do I do the thing with the name? Very simple, in the same way. Define ins bat hash my bat. Oops, my bad. If I use the labeler, I can point at the battery here and give it a name. And that is then the exact name that I'm using in here. So I think you shouldn't then be too playful if you're using that approach. Maybe the name should be something technical like AIRLOCK 1 door outer or something. But that's my programmer thinking. Maybe you can do a more human name like outer door, and that will still work nicely for you. I don't know. But if you do a name like this, I'm not sure if that will work. Probably. What did I want to do with the name? Lost track. Anyway, so I have defined here a word that is a number, and this number stands for this type. And here I define a number that stands for this text. So when I go down here and say write to this of the name, this, then it will know to address all the things of that type with that name. I can have 2 doors with the same name and a 3rd door with a different name, but they may be of the same type. 2 doors would be addressed, the 3rd door would not be addressed. See, that's how that works. So I'm actually not explaining fundamental things about programming here, but about how to program this stuff. But yeah, I guess that makes sense. Let's stick with that. Okay, we have defined the class battery, and I'm loading batch ratio average. And here, wait, I've lost track. So let's start with what the code is doing here. It is writing to all the arc furnace that may be there, because I don't give a fuck. I want to use this feature all the time, and you do too, I think, starting now. Why is the oxygen low? Because of that, and because of this. So activate. And what I'm doing here with the source code is it requires you to build the housing, and it requires you to build the chip, and both of them are not too cheap, and they also consume electricity. And you have to achieve the advanced electronics printer, I think. And this means that it's not for early game, but the arc furnace is specifically something that you use early game, though I also like to use it late game, specifically in this configuration, right? I mean, it's fun. You're just standing inside your station, toss something into an opening, and then some smelted ore, smelted ingot will rain down on you, while the arc furnace is doing all that automatically out there, with even having a queue and releasing all its poisonous fumes into the world atmosphere, and I don't have to care about that while standing inside the base doing all that. That's cool. You want to do that late game too. So I'm saying that you don't need the IC10 and MIPS programming and the IC housing to do that. You can also do that with logic chips. What you would need for this is you would need the logic writer, because you want to address the arc furnace. You place down. Okay, you go into. Should I do this now? Okay, we'll just show you that quickly. Where's my electronics printer? Where's north? Where's south? Oh, I have some solar panels. Spammy spam. Here's my electronics printer, and I can search for logic, and then I will find the kit logic IO, and that's the one. Let's make one just fast, and then I can show you quickly, because we have done that thoroughly in another video. What I'm talking about. Is there some space here? Actually, I could use this one. Yeah, that's about half you thought, right? logic reader to read from a specific battery, logic writer to write to a specific device. That is what we want here in the case of the arc furnace. Then we will use the screwdriver to select out the arc furnace, and then we will select the variable of the arc furnace, activate. And in, then we would have to select a data source. What is the value that we want to write here? Like in the source code, which register do we want to write? And that would be, then you would have to put up a second chip. That would be your slot reader. Maybe we can put that up too. Slot. Batch slot reader? No, I want to read only of one device. Slot reader. Then we would say, I want to read off the arc furnace the import slot. Sorry, it has the import and export slot. Import is where the stuff comes in. And I want to read off this import slot the property occupied. This will then give this chip the value 0 or 1, depending on whether the slot is occupied. And this value would then be given to this chip if you have chosen this chip here as the input value. And then this would be handed over to the activate button. And another thing about logic chips, the writer will not write a value all the time, only when the value changes. That might sometimes be relevant to the kind of concept that you're trying to make happen. Actually, what you're seeing here is typical for when this thing has been programmed with MIPS, because I'm just bluntly writing the value again and again and again. But if you do what I just described here with the slot reader and the logic writer, that will not happen. It will indeed wait for something to be in its import slot, and then it will start smelting. That can also have its downsides, because I think if the device is off and then receives something in its import slot, then the writer will already have done its duty, because from its perspective, the value changed, it wrote the value, and its duty is done. Oh, wait, what's that? By the way, this is F3 for the console, and help shows you the commands. And if you're stuck at some point in the game, you can't get to the menu or whatever's happening, press F3, type exit and enter, you're back in the menu. So the arc furnace, yeah, when you then turn on the arc furnace, then it will not receive the information turn your activate, because that has already been sent to an arc furnace that is offline. So it's nice to do that with MIPS, brute force on every cycle. And this is not the speed at which the code runs, this is just the speed at which the glowing effect is taking place. The code is a bit faster. Now, back to the source code. The arc furnace is now behind us, let's continue. This was just for teaching. Okay, what we did before is we were loading, you know, L and S is load and save. We were loading from a device. Okay, I have to teach you something else. If you write into a device, then you tell the device type and name and stuff as the first value is here. Or write batch, then when I want to do write batch, then I write the type here as the first statement. When I load, then I want to load something into a register. And then the first thing the program wants to know is, yeah, where do you want to load that? So, where do I want to write this? Where do I want to load this? The same even is true for example, mathematical stuff like subtraction. I can say subtract into the register R0, register R10, and 15. Now I'm subtracting the number 15 from whatever is in register R10, and the result will land in here. So subtract into this from this. This can even lead to quirky stuff like this. Subtract into register R0 from register R0 the 15. So first it will do the subtraction, and then the result will be put here. So it's not a problem that I'm suddenly using the same register, not a problem at all. Except now, of course, the value has been overwritten. So next time I want to do this subtraction, or want to use the register value, it will have changed. But okay, that's obvious. So first you you say where. I write into this device. I load into this register. So I load batch into this register from all the station batteries, their ratio, and what is the program supposed to do? You know, remember the batch reader chip? It wants to know what to do with all those numbers, and that's what I write here. We have average, we have sum, we have the maximum, we have the minimum, and then I think we have seal. No, okay, that's different. That's there's a seal command here. Yeah. Okay, that's what that does then. So instead of loading into register R0 from the screw D0, The setting. Why the setting? And because that's the value that it holds. Okay, let me look at the chip again. Here you see 6 values, right? 1, 2, 3, 4, 5, 6. But that's not true. You're seeing 7 values. 7? Yep. The chip itself, the housing itself, also has a value. You can address this value with D0, D1 until D5. And you can address the housing itself with DB. Same for your filtration machines. Over here we have one. These things have this little lid there. It can be opened and there can be a chip in there. And you can also use DB, and then you can address that device. And here we are addressing this device. And if you want to set this value, I mean, you can read this value, and you can actually see the tooltip here. You can see the station battery ratio, not just up there, but also down here, because I just decided to write it also down here. But you can also read from here. And you have already seen that when you say from which device to read or to which device to write, then you also have to define which value do you want to write or read. And here we have to do the same. When we say we want to read or write to the housing, or read and write to these screws, then we have to say, in this case at least, it is the value setting. The value setting, just like the value mode and the value on and off and lock, which you can all look up here, for example, are very standard values which occur all the time. The value setting specifically so, because, for example, logic values, up here we have the LED, and if I write to its setting value, then that's the number that will be shown. If I write to the setting value of the dB, I will see that number. If I write here, and so forth. And so if I used, before I unscrewed this, we had this batch reader which read all the station batteries, and that was the value holder of that. And then here I said this shall be that value holder, and then the setting of this device was to be read. Basically, I think, okay, maybe I'm talking bullshit. I mean, I was not reading the setting within here, but this was the setting within here. You know, the batch reader was creating a value within it in the value holder that is setting. And so I read here in the source code from screw 0, device 0 that is assigned, I read the setting. But I no longer do that because we don't need that chip anymore. We can just use this statement and that up there. Super convenient. I mean, once you have learned that, that is power, isn't it? That's what I was talking about. The caveman and then the cars and then the crane and then the remote control omnipresence kind of thing. I am just expressing my will, and reality is obeying, is doing it. This is not me having to screw and wire things up and 5,500 chips. This is just me writing it down in the language that this reality understands, and this reality will then obey, and I will move on with my life. Thy will be done. That's the goal here. That's the goal that we are trying to achieve, that reality shall have versus us, so that our reality becomes fantasy. And that is also the secret of the golden rule. You know, the golden rule that we have found is kind of a good foundation for coexistence. Like, don't do to others what you don't want to do them to you, you know? The actual truth of that is, thy will be done. Because you cannot be sure if your determination of what the other guy would or would not accept is correct. Ultimately, what this path that we're on as mankind, this apocalyptic path, will lead us to is that we can also all just say to each other, thy will be done. Whatever that may be. And this also means that everybody's will is to be responsibly polished and beautiful. And that's also why we're experiencing this wicked times these days, where someone says, hey, I don't like how you're expressing yourself. And then I'm saying, okay, that might be the case, but I don't give a fuck, because I have to draw the line of thy will be done at some point. So we have found some answers on that front yet already, but that's what this is. You know, we're getting closer and closer to that realization, and closer to implementing that level of coexistence, where the golden rule is no longer sufficient, because the golden rule implies too many assumptions. You cannot know the other guy. You can only accept their will. That's what we're heading towards. And that, I think, is a bit eye-opening as to what the world really is. But, okay, let's return to the topic at hand. I'm expressing my will and the thing is doing it. Here, then we have this value here in the register R0, and then I'm multiplying into register R1, the value that is in register R0, by 1000. So if the value is 1, then it will become 1000. Actually, I'm a bit confused. Shouldn't that be 10,000? I mean, okay, maybe yeah, that's maybe what happened. Let's just put that source code in here in hopes that it's not completely botched. Look up there. Ah, yeah, okay. See, I mean, the batteries are kind of full. I will do something else. Let's go in here and look at the value that is being loaded here. Instead of writing this mathematically raped value into the housing, I will just write the original value, and then we can see if what I'm about to say makes sense. This thing is showing 768, and this thing is showing 0.767. So indeed, yeah, what happened is that when I had my console open, it was typing stuff and it ended up in the source code. I overwrote the 0, that's why. Okay, we multiply this 1 by 10,000, so we have 10,000 up there, and then we round that value to the next whole integer with this statement into that register from that register. So, and then I prepare in register, actually, you know, with the registers, that's a bit annoying, isn't it? I mean, how am I supposed to remember that? That's annoying. So we can do this, ALIAS, then I make up a name, let's say B ratio R0. Henceforth, oopsie, henceforth I can refer to the register R0 by this name. Of course, this requires me not to have recycled registers, which is something you should really try to avoid, because if I now just would go down here and replace every register R0 with, actually that should be working. Only then I would be reading B ratio, when in that instance it would not actually be the ratio. So let's not do that now. But in concept, you can use these aliases, and someone in the Stationeers forums on Discord, great forum, a much better climate than on the Steam forums, where everybody's kind of coming from a world of I shoot you dead, now I won, now I teabag you, her. But in the Discord forum, we are also all more scientists and calmly minded, so come over there if you want to discuss facts instead of throwing your ego at other people, which is something that everybody should try to learn to not do in reality also, right? Because we're heading towards that ultimate point where we will either be all enslaved by the demons or we will all be angels, right? Logically. So, ALIAS, they showed me that it makes sense to just start with R15 and then next ALIAS R14 and stuff like that, because then you can just keep down here, then you would use those names, but up here you would use I mean, down here you would use those names, of course, but in some instances you might actually use a register itself instead of a name, and that would be register R0 or R1 or R2 for temporary values. So then you could easily do register recycling and do the same thing, use the same register again. Yeah, you know, so start with the high registers for the naming and use the low registers for on-the-fly stuff that you will toss out in a few seconds. Okay, rounding, and here I prefer register R2 to be color.green. This in turn is a number, and this might be the number 25 or whatever, and this is not then a special color green number 25, it will just be the number 25. So, I mean, preparing it that this only makes sense if I use this R2 then in a meaningful situation. I mean, I can do whatever the fuck I want with it, but if I want something meaningful, then I have to use it meaningfully. And so here down here, we're writing to the device that is connected to screw number 5, but screw that approach, right? In the future we use a name approach. Into its value color, whatever is in register R2.
Waste tank caution.
Ah, come on. And then we will write the color green into that register. And here I'm doing something we haven't yet seen, but you can see it's going to be a branch command. I branch less than or equal So a branch if register 0 is less than or equal to 60% to color yellow, and a branch if less than or equal 40% to color red. And here's something, a trap that many people often run into, myself included, or maybe it's only myself, I don't know. You might put this line up here and this line down here, but then your source code will not work. Wait, or am I actually exactly wrong? Maybe this code had a bug this whole time, and I'm trying to tell you, don't make this mistake by having this mistake and flopping it around. So let's see what the code will do. If the value is below 60%, then it will show you yellow. If it's below 40%, it will show you red. And I see now that there's indeed a bug in here. God damn it, there was a bug in here this whole time, I didn't realize. Why is there a bug? Well, I will never... Wait, sorry, I have to shut up a program. This other program that I keep shutting up here is actually one that I wrote myself, because programming is something I kind of do. It's a manager for things that I have to remember, and it's really awesome. If you would see it, maybe you would want to use it, actually. No. Okay, so if the register R0 is below 40%, then we want to switch to red. But we will not arrive here, because for the register, for the battery charge, to have reached a value of 40%, it will first have to have passed 50% and 60%. And so up here, when we check if it's below 60%, we will already jump down here. And, oh, actually that does work. See, okay, okay, I was assuming that I was using this command, branch if less than or equal. And then I would jump down to my little marker, to my marker, and then down here I would execute, and then I would jump back, for example. There are other ways to structure the code, and this is not the way I do this these days. And then this marker would never be reached, and so we would never get to see our red. So we would have to put that up here. You know, first it checks is it below 40, then do the red thing. If it's not below 40, then we will reach this line. And it can check for 60. If we do this, it will check for 60, it will do its thing, it will never reach 40, so it will never show red. But in this case, it's different. Because I'm not using the branch less than or equal command, I'm using BLE-AL. AL is a special register which remembers the position from which you came. So I'm saying branch down there, but remember from where we came. That is here. And then here we write into register R2, which is our color holder, that we want it to be yellow. And then we jump, this is just a blunt jump command, we jump to RA. Okay, maybe I said RAL, sorry. The register is RA, and then you jump to that register, whatever that's holding, which means that we will end up here to the next line. So I'm branching down here when it is... Let's say the battery ratio is 10%. What happens then, it branches down here, sets the register to yellow, then it executes this line, realizes, oh, it's red, branches down here, sets the register to red, and goes up here. So you can see there were quite a few programming errors in here. I mean, okay, not quite a few. There's like basically a programming error that will not actually kick in. And let me turn down the music slightly. Or should I keep it up? I will keep it up. I hope it's not too annoying. And then we'll do this, but that's not the way it should be. And also, I personally prefer not to use this AL branching. I would use different structures. Okay, let's continue. And then it goes and writes into my LCD, which is connected. My LED is connected to D5. We want the value in there, which is the battery charge. We want to use this mode, and we want to use this color, and then we continue the code. So what the code does is activate arc furnace, load battery ratio, decide color, write color and ratio into the LED, and do the same again and again and again. That is what this code does. Wonder if it's still working. Maybe. While we're at it, this is my indoor temperature, which is nicely held in balance by my nice automatism. Why is it so cold here? Huh. I don't know. And this is my pressure, 87 kilopascals. That's nice for the plants and good for breathing. And this is already yellow because this is my CO2 ratio and I'd rather have it at 50 or higher. Okay, now here's our AIRLOCK. Now I want to show you something very cool that has nothing to do with programming. Here's my AIRLOCK. I'm working out here. I'm going to my AIRLOCK and here's my little rack. I can put some stuff in here that I want to take inside. Of course, I can just toss it down here. That's also viable. But depending on planet, you might not want to do that, or you want to make sure that it isn't blown around by some kind of overpressure event when you, for example, empty your waste tank. So you can place it here. Just have a rack here, put some stuff down, and I already prepared a chip and an IC10 for what you want to do here. Let me first empty my waste tank. I can also show you some of the rest of my ridiculous base. Here I'm using a mix of IC10 and chips because I didn't know yet how to read directly from devices. And here I'm using more than 5 or more than 6 devices, so I had to split it up into 2 chips. That's why I need the memory chips. It's actually 3 IC10. It's ridiculous. I could have done all of that with one, now that we know how to define our thing with hashes, you know. Yeah, the large tanks you basically never need. I'm not saying not actually never, but in really most cases you will be able to cope with the small ones. So let's get rid of that. And look at some new stuff that I built. Actually, I wanted to show some advanced AIRLOCK programming down here, but then things got too complicated. And so I rather don't want to do the simple stuff over there. So I built this specifically for this video, and now I'm not using it. So let's go to my indoor base, my little greenhouse on the moon, and let me show you what I've been doing so far. So far I close this door manually, and then I open this door. Immediately the pressure in the AIRLOCK rises to the same pressure of the indoors. Actually, the pressure decreases because now there's more room for the gas. This is the AIRLOCK temperature, and yeah, this is my little station here. The computer. The laptop is very useful, if you've seen, but the local computer, localized computer, the firmly installed computer is also very cool because you can just select the chip or the device that you want to program, instead of having to throw down the chip back and forth all the time. So when I want to leave, what I have to do is I close this door, I turn on the vent to suck the air, and then it's gone. I can see and hear that the pressure is gone. I turn it off and I can go outside. That's of course risky, and quite often I failed to do that correctly, and actually I played together with another guy on this map for a short time, and then well, one of us was outside, the other one was inside, so the doors were not optimal for the purpose. I guess someone wanted to go outside, but they couldn't. Yeah, it was like this. I went outside, he was inside, and so we had lost some atmosphere by that. It's better if the AIRLOCK is actually automated. So let's do that then. You know how to do that with consoles, I hope. This time we're going to deal with programming. So there's already the gas sensor, which is only here for the temperature, but now we can also use it for the pressure. And this thing is the big boy vent. You know, the active vent, the small one? That is like the most used device in the game. There. There's a larger variant of that, which requires some advanced ingots, I believe. And that's the powered vent. And this one even has a large variant, that's this one. It's really fast. And its purpose actually is not to suck dry very fast such a single room, but it, as opposed to the active vent, the powered vents can suck from more than one world grid at the same time. So the world atmosphere doesn't have to realize, oh, there's some space, I'm gonna stream over there. And then the vent is saying, thank God, now I finally have something else to suck. But instead it's like sucking from multiple world fields into the depth and into the width, I don't know exactly how much, and so you can actually empty out entire hangars. And I think that thing was actually implemented into the game because of the trading, you know, because for some traders you have to actually build hangars with their own atmosphere and actually landing strips and such. It's awesome. I haven't done that yet, but it's great that we can do that now. Okay, So let's start. Put down the housing. The housing has 2 connectors, one for electricity, one for logic. So the thing needs to be driven by power, but it needs to do stuff too. That's what the logic connection is for. Okay. As you know, you can join cables by just having the wire cutter in your other hand. The tooltip also tells you that if you don't have it. Here. So it's less complicated. You don't have to cut the wires. You can just place the correct wires down. So you only need the straight and curved wires instead of having to go through all those variations. So that thing is now ready for action. If I put the chip in and run it, the program will run successfully because there's no program yet. And so that's executed without flaw. What is it that we want to do? Yeah, I actually had something prepared. Let me pause the video for a second and load that save game because I lost that code now. Okay, we're back. Recording? Yep. So what is it that we are trying to achieve? See, I said something about define what you want very precisely, very clearly before you go into it, so that what you develop isn't stupid. When it comes to source code or any project that you're doing, or when you're cooking something, I don't know. So what is it? What do we want to do? The AIRLOCK, when I come in and push this button or that button, it shall just close this door and then open that door, because that's sufficient to me. I mean, I don't have a problem with the explosive decompression-ish situation here, and actually I hope that they will implement that in a way that will be more powerful, more forceful, because all this just opening the door, which many of us are doing to accelerate the cycle, is cheesing, right? So I think reality should have a say and blow us around slightly or something. I want that door to open. And if I go the other way, then I want that door to close, this vent to suck the room dry, and then turn off when that is done, and then to open the door. And then we're at the original state again. That sounds not too complicated, but you will be surprised. There's quite some code that we will have to write. But now that we know how to do that, right? Okay. I wrote down some things. You remember that we have to define here the devices that we want to address. So we will have. By the way, why do I say CLS and INS? Okay, that expresses basically in the following way. Let's okay, I'm a bit off track. Define. Okay, let's do that then. First, I want to define the type glass door, so I can address all the glass doors that are on this current cable network. And don't worry, before the video I used the actual network analyzer to check if it's actually wired correctly, because in my past videos I did some programming mistakes, but those were actually not in the program, they were always in the fucking wiring. So at this time I checked those. Did I actually? What about the logic connection? Huh, it seems to be connected. Yeah, okay, let's continue. Okay, here I've defined the type, but now I want to address the individual doors. Okay, that wasn't the wisest way to do it. Okay, so first I have to define the type, and then I have to define the name. So I can say, for example, SBN CS door, and then ins door outer, open 1, so that only the outer door opens. I can also do SB, and just do this, but this means that both doors will open. That's kind of against the spirit of an AIRLOCK, you know? So let's not do that. So what does CLS and ins stand for? For class and instance. That is something that programmers know. But I myself, when I first heard about object-oriented programming, you know, I started programming basically in the early 80s. So that is back then I didn't know about that. I was taken aback by the idea. Class? Why class? What the? No, I don't know the word. I couldn't like attach that to what it was supposed to mean. Specifically in German, it's Klasse. You know, like the class in school, and that's what I had in mind. Okay, what does it mean? It means the type. This means type, and this means instance. In programming, you can define. Let's say we have a number. We have a number. And the number is of the value 10. Number 10. This is not how MIPS programming works, but now I have defined a variable and it's of the number 10. Actually, I have to define the type too. And here then I have an instance of a number, and this number has a value and it's 10. This is the class, and that is the instance. So this is the type, and that is what this is of, you know. It's like when I'm looking at cars, you know. The cars are the set, and the individual car within which I am sitting, that is the instance. So the class is the set. It refers to all potential members, not the actual, but all potential members of the set. An instance means one specific instance, one specific member of the set. So up there, I'm defining, you know, all doors of the glass door kind, and here I mean specifically the outer one, and here specifically the inner one. That's why I use that kind of lingo. What we also need is the gas sensor to find out if the airlock is evacuated. Define CLS sense. Then we want to address the powered vent. Define the instance. There's only one powered vent here, but I want to make sure that any later changes to this cable network will not suddenly turn on some powered vent that I'm not supposed to turn on. It's always good to be very specific. Like I said, the computer is stupid. It needs all potential context. It cannot think with you. And in the same way, you just want to be as clear and as unambiguous as possible at all times. Now, you possibly also have read here, if the program starts and we have atmosphere, we have to consider not just the program, its algorithm, but we also have to consider some edge cases. For example, what happens if I turn on the chip? The chip doesn't yet know what the door state is, what the airlock state is. So what is it supposed to do now? And so we have to deal with that too. That is why I've written this here. See, and that's exactly an example of this thing where you have to go into your pyramid of abstraction, of logic, of creation, by having the right will at the beginning, and then everything else will follow from there. You know, what the original decision was, that's the question. Now, the decision here is to first make sure that we determine what the program shall do at the beginning. If the program starts and we have atmosphere, so we use the gas sensor for that, the program will just assume that we are inside, and then it will set that state. You know, it will be a state machine, you know. We have a variable like R0, for example, and it will have the value like 4, which means we're inside, and 5 means maybe the door is now closing, and 6 might mean then we're evacuating, and 7 might mean it's evacuated and the door is opening, and 8 might mean now we're waiting for the opposite side, you know, waiting for you to push the button and get inside. No, that's what I mean with a state machine. And actually, I'm not sure if state machine is really the right term. I just think it is. Sorry if it's not. So, structure powered vent, if the program starts. So it will then just set that state and jump back to start, and then it will just operate based upon those states. So once we, then it shall wait for the door buttons. If one is pushed, it shall go through the steps. So like I said, if we are on the inside situation, it does this and this. On the outside situation, it does that and that. Going inside is easy, just close the outer door and then open inner door after that. Very important after that, else maybe the door closing might not be fast enough so that the door opening might already stream some air out there in to the moon. I know it would speed things up to do that simultaneously. I'm just not sure if that will lose us atmosphere, so I'm just not going to risk that, so there's going to be an extra state machine step because of this. And, oops, going outside means close inner door and start pumping out the air, then wait until vacuum, then turn off pump and open outer door. Yeah, so let's do that then. We have defined our devices, the doors, the gas sensor and the powered vent, and that is all that we need. Let's go. Start. Yield. And yeah, something else about projects. Jump start. Our main loop. When you, for example, I mean, some of you might have started a project or I don't know what example to use that is approachable by most people. Let's say you have started writing a short story, or you started writing a program, or I don't know what exactly. Then you will be enthusiastic, and the reason is that now this entire pyramid, you know, just imagine a triangle standing in Gizeh or somewhere, wherever, is currently, it's completely open, it's completely your option spaces, like the dream that you can define freely. And so the first step into the dream should be proper, so that all further definitions will not be polluted by those initial definitions. And that's the enthusiasm. But for example, when you develop a game and want to publish it, and you're getting closer to deadline, or not even deadline, if it's about, that's actually interesting. That's a hypothesis I have. I don't know if it is true. I believe that reality affects the mind directly, the human mind directly. That the Newton's third law of motion actually applies to the mind. That's actually the nature of stage fright. You know, when you're standing up there and you don't have any routine yet doing that, and so your future in this regard is completely open, so you're now making your first decision. At the same time, down there are sitting all of those judges whose personal decisions will affect you, at least when they applaud or don't applaud. There's actually a good saying here that everybody should hear. It's not from me. It is, if you live by the cheers, then you die by the boos. Okay, that's kind of the approach that I use also for my videos. I mean, I'm not saying I don't care about you, but I kind of don't give a fuck if you like them or not, which means that if you like them, that's fine, but if you don't like them, then that's just the way it is, and my life will continue. The guy on stage, which doesn't have yet that routine, their routine, not this routine I'm talking about, and doesn't also have some experience with the concept I just explained, will be emotionally affected, and my hypothesis is that this is actually a physical effect that affects the mind directly. And why am I saying that? Because yeah, let's say you develop a game, and that game is about to be published. And when it will be published, the people will see it in the world, and they will be affected by it. So the world will change its state. The people will have different decisions. They will flow differently. Life will change. A small scale, but it will change. And the thing that made that happen is your thoughts, your decisions, your emotions. At the beginning, it was easy. You were just typing out in your probability space here, which was completely empty, and you were enthusiastic and everything was possible. But then things were established. You had to go with that. And most of all, you were approaching manifestation. You were approaching that stage, that moment when you would expose the world to that. And the closer you get to that point, the harder it is. And I think what you're feeling there might actually be the energetic load of the world that needs to change, the weight that is weighing down on your mind. Now you might say, well, I can change the world with my mind. Yeah, that's kind of what we're doing. I mean, if I'm using my arms, there's mind over matter, except in a way that the universe agrees with. And if I'm changing the world by publishing a game, then, which I haven't yet, by the way, then I'm affecting the world also in ways the universe agrees with. So it's not a spirit space where someone imagines something and everything is shaped accordingly, but no, it's a coexistence space with multiple spirits where we have to have some rules. Then I think that's how that works with projects. So let's continue here. So I think I wrote down some states. Did I lose them? I lost them. Whatever. So I want to have some undefined state. Let's define some states. This might be a bit long because there might be things happening in the same way all the time. I'm sorry, I'm just doing this entirely real time, and I actually don't know exactly what to write now. Let's see. So I want to define a value whose name is state 0 fittingly for undefined, and it shall have the number 0. And I will also have a register that will have this current state that we're in, alias state, alias state R15. And then we could already work with that hypothetically, develop that in parallel basically. So when this thing starts, the first thing it has to do, it has to wonder, what is my situation? Because the code is supposed to do stuff, you know? I want the program to serve me, to do something in the world, which means that the computer is an extension of myself. The computer itself is kind of having a will in a digital form that are imbued upon it. And so it has to wonder, what is it that I want to do now? Open the doors? Turn on the vent? I don't know. It's supposed to be correct, so let's look at my text here. So the first thing we want to do is we want to check the state. Let's see. If the state is equal to state undefined, then we want to deal with undefined. Deal with undefined. Maybe that's not the best way to do it. You know, like I'm winging it, like all my videos. And then I want to jump back to start once I have done that here. See, that's the different kind of approach that I'm using now. I'm having some blocks which do some stuff and I jump back to start. Or what I might be doing is I'm jumping within this main loop and having little blocks here, and I jump to the end of the block, and then the next topic comes, and eventually I reach the jump start, and you know. But now I will do this because this is focused on just the AIRLOCK topic, and the AIRLOCK code is going to be complex enough. I don't want to throw some stuff in there in addition, and I'd like to have some kind of functional units localized. Here's this, there's that, you know. That's why I'm doing this now. So BEQ, state 0 undefined. All right. Okay, branch if this register is equal to that state, then branch here, and then say, what did I say up here? What is the mission? If program start and we have atmosphere. Oh, okay, so we have to make a decision down here. We have to make a decision based upon the current gas state of the AIRLOCK. We don't know the current gas state, so let's obtain that then. Here we have the gas sensor. We need a value holder for that. ALIAS, press R14. So before we do this, we want to obtain that value, because once we have done that here, the register will have that value. It doesn't matter where we are in the code, the register will have that value, until I overwrite it, of course. So thinking in this kind of flow is tricky, but you know, programming is not easy, but then again it is. You just have to develop the mind for it, you know. So let's load batch named into register pressure from the device sensor. Now important, instance sensor, else that would fail. The value of that device shall be the pressure. And since we're using the batch command, I have to also define what to do with all those values, of which there will only be one value, so it's kind of irrelevant what I do here, but I like to do sum, because then if I for some stupid reason end up with two sensors in this network which have the same name, then I shall fail, because that will motivate me not to do some stupid shit like that, and also then I will see more easily that that has happened. Imagine I would do average here. This might then lead to a situation where 9 out of 10 times it works, and then the 10th time it doesn't. So it's good to use an approach that is actually, I don't know if that's the term for this. In programming we have a term that's called fail fast, which means that we're trying to make the program fall flat on its nose, or throw an error, or return with an error message as soon as possible, instead of you know, whatever. And here I'm trying to make sure that if something goes wrong, I will probably become aware of that, and so we use sum. Now we have that pressure value. Now down here we can deal with that. So what is that I want to do? If the pressure is, we want to branch if less than or equal. Why do I not just branch if equal? Because personally I feel a bit iffy regarding this whole concept of equal and unequal and such, because these numbers here, they are not integers. An integer number, you know, is 1, 0, 2, 3, is not 3.5. Those are decimals. Well, these are decimals, right? Only a decimal number can happen to be an integer number. 7 is here represented by a decimal placeholder. And so if I do use equal on a decimal and the number is not 7 but 6.9999999, then the answer will be false. That's why I personally feel a bit iffy using the state holder with the integer numbers, but I guess we have to deal with that like this. But here, in the case of pressure, I don't have to accept that. Instead of using equal, I can say less than or equal. So if the value is less than or equal to, if the value of pressure is less than or equal to 0, then I want to deal with undefined, what did I say? If the pressure is 0, then we are outside. Yeah. Let's prepare that label here. And if the pressure is not that, then we will assume that we are inside. So what is it supposed to do then? It is supposed to set the state of the state machine and then jump back to start, and then up here we will check again what state we have and act accordingly. And what I would like to do is, in the case of outside, I would like to open the outer door and close the inner door. That is not something we have to program specifically for this edge case here, not at all. I just have to set the state here that would be within that part of the rhythm. You know, we will not have just one state, but like 7 or 8 of those, and I will just say set that intermediary state that is between going from the inside to the outside, or from the outside to the inside. They will do that thing that I wanted to do. So let's see what other states that we need. We will have the state outside, for example. Define state 0. Or should we start inside? It's arbitrary. It's an arbitrary choice. Let's start outside. Outside, because that's where we happen to be. State 1 outside 1. This number here is not relevant, because I will no longer use it. I will just use this name instead of it. And this name tells me more. I'm using this number here again because, I don't know, for clarity, and it doesn't hurt, and because if I see this number alone, then we'll already know, okay, 1 is greater than 0, so that follows logically. I don't have to read this here and digest this text and then possibly misinterpret its meaning. That is when I'm having this number in here too. So state outside. Now we are outside, we're pushing the button to the inside. Basically, while we are outside, the state machine will check, is the button currently being pushed? Yes? Okay, now let's change the state to, yeah, what is it supposed to do? The moment we detect that the button is being pressed, we can immediately trigger the closing of the outer door, and then we have to wait one step because we don't want to open the inner door instantaneously, because it's risky. So we will have define state 0 opening inner? No, outer closed. Yeah. Wait. Okay, it's a bit, seems a bit wild, but state 2 would be we wait until outer is closed. Okay, and then obviously this state will be over only once outer is closed. So what's the next state then? State 3 is we open the inner. But you know what that means? This will wait until this will wait until the outer door is closed. This means that the waiting of this will eventually be over, and then it will say, okay, let's change the global state to the next step. But it can do more than that. In that situation, it can also just decide to open the inner door, and we don't have to wait for the inner door to open. So what this state can do is, once it has done waiting, it can just open the inner door, and so the next state is already us being inside. Now that was uncomplicated. Inside. So undefined, we are outside, we push the... Okay, let's continue. 3. So now we are inside, and some loon pushed the button to go outside. State 4. State 4. State 4. We are inside, we are pushing the button. The first thing to happen is wait for inner closed. Actually, is that what we are doing? I mean, once we push here on the inside, we are waiting for the button. When the button is pushed, we change the state to the next state. And what we can do, of course, in the same breath, is we can start the pump, And we can also trigger the closing of the door. This would of course mean that we start pumping very forcefully while the door is still open, and this might mean that we suck some ingots or stuff lying on the ground into the door, into the outside. But let's risk that and see what happens, and maybe later we see that it's stupid, and maybe later we will actually alter the source code accordingly, and then hopefully see that it's not so complicated. Except, yeah, of course I will have to edit every marker where this is occurring, because then the number also has to change. Okay, that will be a bit sucky. Anyway, so when we're inside, someone push the button, then we want to turn on the evacuation thingy, and we want to close the door. So what we are doing here is not we're waiting for inner closed, we're waiting for a vacuum. And when that vacuum has been achieved, what we do is we turn off the vent, and we open the outer door, and we change to the next state. But guess what the next state is? This one. The outside state. I'm just not sure what would happen if the door is in the process of opening, and then I hit the button. I'm not sure what would happen. There might actually be an error that happens then, that we might lose track of the situation. But, you know, we will first first operate it slowly, and then maybe it works. So the next state that we will need here in the simplified version, outside. So we're done. We have defined all the states. So if we are down here and we realize we are undefined and we realize that the pressure is 0, then what we would like to do is we want to produce the outside state where the inner door is closed and the outer door is open. And I realized that state doesn't exist. I took some shortcuts here. I explained that actually, and so I now cannot do that. We can also just ignore that and just assume that the AIRLOCK will have a proper state at the beginning, and I will do that just now to keep things simple. So if the pressure is less than or equal to 0, then we are outside, and so we will move this. Yeah, there's the move command. I don't know if I have that up here already or somewhere. The move command just writes a value into a register. And the register shall be state, and the value shall be state 1 outside. And then we jump to start, and then we will deal with that state. And if we are not outside, then we are assuming that we're inside. That's this state. Move state inside. Oh, right. Of course, that would have been stupid. Okay. Now let's deal with individual states. What if we are outside? If we are outside, then we want to check if the button has been pushed. That is similar like to the gas sensor. We want to prepare that value up here and then deal with it whenever we desire to deal with it. So outside check button. If we do this, something's commented out. It's still in the code, but it doesn't hurt. Yeah. That's also why this is red up here. So how do we get the button value? That's a bit tricky. I have to do something... I have to basically prepare the doors. So, write badge named class door ins... Actually, no, I want to write to both doors. No, but I only want to write to the glass doors of this AIRLOCK, so I have to do that individually. I don't want to risk anything for later station changes. Class door, ins door, outer, and what is that I want to do? I want to switch it to logic mode. Here are the logic values of the glass door, and one of them is the mode. And mode is, like I said, something that many devices have. And in this case, here is documented 0 is operate, so I can push the button and things will happen. And 1 is logic, meaning if I push the button, it would still be green, but it won't do anything. I think it will be green. Anyway, it won't do anything. And what happens, it's a bit tricky. Let's go to the source code. Press pause. And so first we switch both doors to logic mode. this is possibly already happened because it might not be the first iteration of this code, and actually I could put this up here. Actually I should, because there's no reason to do that again and again. There's no way for the doors to switch out of logic mode, except if there would be another chip running. I think there could be another chip running and program the same doors. There would then there would be probably some kind of race condition. In programming, that's what you don't have to know that here, but in programming, a race condition is it's called race condition because they're basically like two people racing with each other, and they're close. You know, you're looking at them from the side, and you can't even tell who's first. But and they're both doing stuff. And so you can't tell what exactly will happen first. Sometimes this will happen first, sometimes that will happen first. And so in programming, we have, when we do multi-threading, we use synchronization in situations where threads are accessing the same values. And that's a race condition. And if you would have two chips here addressing the same device, you would probably have a race condition, no matter how this game is actually implemented, because you might be assuming that the door is closed, or you might be assuming that the door is opened because you made it so at some point. But some other chip might have made it differently, and you're not aware of that. So that's still a race condition. Anyway, so let's ignore that. We have a source code here, and we are saying the doors shall be in logic mode. Now we want to know if the user has pushed the button. Load batch named. Actually, yeah, named. We need batch named, because I don't want to read any other doors. I should have separated this circuit out, but okay. What is it I want to do? I think it's setting. There's the setting value. Let's say the door is currently closed, then the open value will be 0. And I push the button, then the setting value, which is also 0, will flip to 1 when the door is in logic mode, and the door will not do anything, and the setting will stay at 1. And I can actually use code then to write the value back to 0. It doesn't matter, it's not important. And then I can push the button again, it becomes 1 again. You know, it doesn't matter. But the thing is, I can tell the door what state it shall have. Basically, if the door is at 0, which is closed, and I push setting, the door will be at the odd state. It's ought to be 1. And then I can just actualize it by copying the setting value into the open value, and then the door will be 1, it will be open. And if the setting is at the same value as the open state, and I push, when the door is in logic mode, that button again, then the setting will flip to 0, and it will stay there and kind of be altered again by me interacting, and, you know, vice versa, basically. So I load batch name from this door, the setting, and, you know, again, that's that bullshit. And then I have it in, you see here, I have to define the batch mode. I just did that. No, I did it wrong. When I say LBN, when I read something, I have to say where to read that. So I have to define the register. And I will use actually a temporary register here. I will show you why soon. Because now we have off this one door the setting is either 1 or it's 0. And if I want to know if the button has been operated, then like I just described, I have to compare the button to the door's current open state. So let's read the door's current open state, load batch name, blah blah blah. So copy that into register R1, whether the door is open. And then I will subtract into register R0. Wait, let's see. I will subtract into register R0 the difference 0 and 1. So let's see what happens. If the door is closed, 0, and I push it to be open, then in register R1 here at the end, I will have 1 minus 0, which is 1. So I will know that the button has been pushed. And if the door is currently open, then the open is 1, and I push the button, then setting will become 0. Then basically, I mean, to summarize this, this will have the difference. If the setting and the opening value are on the same level, then I know the button has not been pushed. The button situation is satisfied from our AIRLOCK perspective. And so I have to now compare this register R0 to whether or not it is 0. So we will have now a variable up here, ALIAS button was pushed. Which button we don't care about. We just want to know if someone wants to operate the airlock. Button was pushed. And I can actually initialize that. And this is also a nice way to kind of headline this. What is it that this source code is doing? Blah, blah, blah. But instead of that, I can do this. Move into button was pushed, the value 0. Then I will know that this code block of consecutive lines probably deals with whether the button was pushed. So I initialize that with a 0. Then I'm trying to find out whether this button was pushed. So I read the setting, I read the open state, I subtract into R0 the difference between the two, and then I can say B EQ R0 0. There's actually a branch statement that checks specifically whether a register is 0, but you know, I mean, why should I learn another word here if this one does it, you know? Well, it's easier to see. I mean, the more elements you have on your page when you do your desktop publishing, the more font sizes you use, the more font styles, the more chaotic it will look, the harder it will be to discern. Of course, you, the one who decided that, put a lot of thought in it, so you know this bold and this headline and this underlining and this spacing needs this, means this, and this means that. That's how you read that. But an outsider, and for those who are creating that, see also my videos where I talk too much, they don't know what the fuck you mean. They don't want to read your document. So less is more when it comes to fonts and desktop publishing and page design and font sizes and that. And the same goes for base design. When you use colors, less is more. And the same goes for this source code. The fewer commands I use, the fewer different commands, the easier it will be for me to read the source code later when I don't have in mind anymore what this is. So now, button was pushed, here with the difference, and if register R0 is equal to 0, then button A was not pushed. But if button A was actually no. We thought, I didn't think of that actually. Branch relative to, and here we say move into the register button was pushed, the value 1. So what's happening here? First we initialize the register button was pushed with a 0. Then we read of the one door, the current setting, whether the user triggered the button. And then we read the open state, and then we create the difference between the two. And if the difference is 0, then this means that the button was not pushed now that the door is open, or now that the door is closed. Since then it has not been pushed. So we don't want to assume that the button was pushed since it was not pushed. And so what we do is, if the button was not pushed, if the difference between these two is 0, then we just skip this line. This line would say that the button is pushed. Now what happens if I replicate that whole stuff for the other door and then also do this, then we will not have a problem, because either this value was set from 0 to 1 or was not set from 0 to 1. But we will not overwrite it accidentally, because the only writing that we do is 1. That is also why it's good that I'm just initializing this thing here at the top instead of doing a write of 1 and or 0. You know, I'm writing either 1 or 0 down here. If I do that, then I will have trouble with the second door. So let's do the same thing again. We can now recycle, thanks again to that unnamed Discord user, the door inner. Same thing again. The entire thing again. Whoops. Let's see. We read from the type door inner, setting sum, into the other register, open sum, we into register R0, the difference between the two, and if the difference, branch relative, if equal, register 0 to 0, then we skip this line, else we execute this line, the button was pushed. Okay, that, I don't know what that is. Let's ignore it. So now we have the information, the button was pushed, and now we also have, let's remove that and move it down here. Why? Because then when we're down here in the source code and we look upwards, and we have some spacing in between, and up there's a cluster of lines, then we try to find out, okay, what is this cluster's meaning? When I look at this line, then it will quickly see, oh, this is about preparing the values, the pressure value. And then this is, that's about the doors. Yeah, right. because I'm more likely to read it from below when I'm programming than from above. So now that we have this, check outside check button. Let's go there then. Here we want to check the button. If the button was pushed, what is it that we want to do? Actually here we have branch less than or equal. We can do this, I believe. This means not equal. If it's not equal to 0, then there is pressure of some kind. Negative? Actually, if it's negative, yeah, I think there could potentially be some kind of decimal shenanigans, because the computer isn't magical. It uses bits and bytes. Everything in there is and OR and XOR and that. That's really all it is. I mean, it's baffling. There are some games out there which you can play which make that clear to you, and then you realize, what the fuck, that's all it is? It's and OR and XOR and some memory writing and stuff? That is all it is? And then I can play Stationeers on that? Yeah, that's what it is. It's baffling. And so this is how you know, the decimal numbers are implemented, and so that's basically, there has to be some simplification to keep it performant. And so maybe sometimes you have a decimal number that should be 2, but instead what's stored in there is 1.9999999 or 0.000009 instead of 0. That is possible. And so I'd rather here I go for less than or equal. If pressure is less than or equal to 0. Deal with undefined outside. No, we already had that. I'm in the wrong place. Here, outside check button. Did I botch something? Probably not. So outside check button. Now we want to check the button. If the button is not equal, if this value is not equal to 0, then what is it that we want to do in that case? Or is that the wrong check here? I don't know, but what do we want to do? We want to go to the next stage, right? I mean, we are on the outside. Is that right? We're on the outside and we're checking the button. State 1, we're on the outside. And here we're saying wait outer closed. So we know one thing already. One thing that we will do down here, if the button, only if the button was pushed, is we will say move state to this. But we can wait forever for the door to close. It won't close, we have to tell it to close. Write badge named to class door instance door outer. It shall be closed. Open 0. Now the door is closing, and now the next state that we have is we want to wait for that door to close. But when shall these two things happen? I think we can shorten this and we can say if the button was pushed is 0, then we don't want to do that stuff. And otherwise we want to execute the rest here. So that's that. The outdoor is closing. This, let's save that. This seems like it's a lot of hard work and so forth, but I have been programming for, I said in another video that I have been a programmer for 40 years. That's not true. I have been programming for 40 years. I started as a child playing around with some basic and then returned to gaming and then some basic lines, stupid crap programs. I have been a programmer professionally for 27 years though. 28? I'm not sure. Anyway, even now, even still to this date, the following happens to me. I program and program and program, and then I realize when I type the last line, I'm done. You know? You go so deeply into the individual components of the thing, then you complete this component and that component, and suddenly you have completed the last component, and then you realize it's done. And you actually have to take a look around and realize, yeah, it's done. And that is what we will experience here. We actually are approaching that point already. Because we already have one stage, and the others will be quite similar. So now we have this. We have to branch if we have that state. State 2. Sadly, I can't use some kind of autocomplete. A proper integrated development environment, of course, has autocomplete. But I mean, this is a game. This is already complex beyond belief. Outside. Wait closed. Don't have so much space here. So if the state is this, we're going to go there. Maybe I should actually Should I now transport those lines below? Now, I don't want to scroll like an idiot all the time, and the scrolling is stupidly slow in this game in all the windows where you can use the mouse wheel. I hope they change that soon, and because it's easy to do, you just have to change the multiplier to the mouse wheel value that you're reading, and then it scrolls stronger. I don't know if their mouse wheels are potentially set to something very powerful, and if that even affects the game, whatever you set in Windows, and then that's why they haven't changed it. I don't know. Anyway, James, start. So, outside, wait, closed. We are waiting for the door to be closed. Let's look at the door. And here we have idle. That's the thing. We are waiting for idle. I'm not sure. I see if I set the open state, if I set the open state from 1 to 0 so that it closes, then it will have that state, but meanwhile the doors will still be in motion. So I can't just look, is the door now closed? I have to look whether the door is idle. I've set it to closing, and then I can also, now I would only have to check if it is idle. Of course, if I want to be thorough, I can also check whether it's actually closed idle, but okay, we don't need that here. Idle is what we're looking for. So outside, wait, closed. Load in a temporary register, because we only need that value right here. Load batch named class door outer idle sum. Right, where do we want to load that? Huh. It's still wrong? What the fuck? Ins. Man, I'm stupid. Ins door outer. So class door ins door outer idle sum. If the door is BNE, not equal, register as this is 1. I assume that it will just express a yes or no, and that is always expressed as a 0 or 1. Though I believe that if you use actual logic comparisons, there are some logic comparators in here, they will just check if it is 0 or non-zero. I don't know if that comparison will actually first round that value to a full integer, so I don't know if 0.1 is a 0 or is false or will already be read as true. We should investigate it at some point, but let's ignore that now. So if the door is idle, will probably mean 1 if it's idle. If it is not idle, then we want to jump to start. Else we want to change to the next stage. What was the game plan again? Here we wait for outer closed. Once it is closed, we can immediately start opening the inner door. Actually, we can check that. We'll add this bit of source code and we run that thing. We test it out. Yeah, let's do that. So wait outer closed. The next one is state inside. Here, move state inside, but we also want to write to the paused game inner door open 1. Ah fuck, there's a bug in the editor which deletes when I press delete here, not just the last character, but if I have reached the last character and press delete, it will actually get the next line up here. I'm convinced this is related to line feeds, because the new line character in the text file, you know, when I do this, there is a character there that's invisible that creates this new line. It's expressed in different computers or different systems in different ways, and stupidly, really fucking stupidly, we still have this tradition of having 2 characters in many cases, and that is, I guess, what they stumbled upon here. There are 2 characters, or only 1, or they're assuming 2, something like that, I'm not sure. Hope they fix that. So we want to reload whether the outer door is idle. If it is not idle, then we just return to start. If it is idle, then we want to open the inner door, and we also want to move on state-wise to the state inside. Why is state small lowercase now? Maybe because I typed lowercase. Oh, that would be the reason. So then we are inside. Okay, hypothetically, now we have an airlock here. When you are on the outside, you can push the button and the outer door will close, and only when it is closed, the inner door will open. Let's test that out. That would be a chapter in the video, I hope. Export. Save. And now, I would push this button and it's not working. Why is it not working? Now that's tricky. We could, for example, one thing we can do to... Oh, the door is not affected? What is going on? Okay. Yeah, one of the things you have to do is you have to turn the motherfucker on. And then you're still frustrated. What's happening? Huh. Sad face. Is the logic connected? Yes. Everything's connected. Okay, we can do some bit debugging here. Let's simplify the source code by just saying this is our not so important. Here we will just say write badge named class door ins door outer open 0. The door should now close. If it doesn't, then we have a fundamental problem. That's how you should approach this, you know? First check the simple stuff. The door is not closing. Aha, we could have debugged for hours. That wouldn't have helped. But why is the door not closing? I can still operate it manually, so obviously it's not in logic mode. I don't understand. Let's see, maybe the name is incorrect. I gave it a name, didn't I? Airlock door outer. Oopsie whoopsie, I think... yeah, I didn't yet name the doors. That can't work then. So, outer door. Confirm was not necessary. You should never click OK in a dialog in Windows or anywhere else when you don't actually... Oh right, the code is running. When you don't actually intend to change something. Always do exactly what should happen. Not something that happens to possibly not be wrong. No, only what should happen, if possible. Thy will be done. That's the rule that the universe is casting at us, and it's expecting us to do the same. So, let's go into... The door closed because yeah, okay, see, our test is working. It's forcing the door closed. Let's name the other door. I think I can do that freehand. Okay, let's try that again. It's cancel, paste, inner. Do I have to name some other things? I do. How long is the video so far? 2 hours, goddammit. I did a 3-hour video recently that was about 30 gigabytes of upload. That wasn't fun. So, 2 doors are named. Now we need to name the sensor to make sense of this. Cancel. Sorry. I will let myself out. And the AIRLOCK vent. Now I don't want to invent another pun and just name that thing. Okay. So now what we want to do is, my mouse isn't proper. I have a Razer mouse, you know, I like those. They're very good button-wise and so forth. But I think their support is absolute dog shit. And I also think that their software has become absolute dog shit by now, so I will no longer use them. I will use a different one. I haven't yet found one. Logitech is also shit. I mean, sorry. That's my experience. Sorry. If someone else disagrees, do that. Make a video, talk about it when you have a captive audience. So, I will no longer do this, but I will keep it up here. And export, save. And now, oh, huh. Obviously that was not intended. I think what just happened is it ran into the state undefined, and then it made the wrong decision, and so that's why the door opened. Now the doors are in logic mode, and I can no longer operate them, which is a bit sucky. So to debug this, first, huh. Oh yeah, that's what we can do. Uncomment this, change this to 0, export, daringly run. Now the doors are operatable again. We can do this. Oh, no, I can't. One of the ways that we can do to debug code is to write one relevant value to the IC housing, you know, and that's very easy to do. Damn it. So we are going to do that. But first I will try to debug the code where I think it is probably fucked. So up here, before we do anything, I want to just write, not batch, not name, but just write to a device, this one, which is the foundation, into the setting, the current state. Then we can see what the machine is thinking, basically. So at the beginning we have state 0, 1, 0, 1, 2, 3, 4. And then it branches down here. And then it will jump back to start. So if the pressure is less than or equal to 0, so pressure is of relevance, then let's see what the pressure is. Actually, let's not write the state. I could leave this in, I could just overwrite the state, but I don't want to risk that. I mean, overwriting a register value is one thing, but in this case I'm overwriting an external machine's inner workings. And I don't want to run into some kind of kerfuffle where they might have some inert values or might be locking down a value while some operation is going on. I don't know if that can happen, so I'd rather not write externally with overwriting. If that would be a register, I could just leave that in. So write to the housing. I want to know what is the gas pressure. And then jump back to start. So now we see here 0. And now we see the room pressure. So that part works. We're getting the pressure from the gas sensor. If the gas sensor wouldn't be connected to the network, then the register would actually have the value NAN, not a number, I think. And then we would see that here. I'm not going to test that now, because another video did that for us involuntarily. So we have the pressure. Down here, we see if the pressure is less than or equal. Here we can see the comment, branch to line C if A is less than or equal to B. Branch to this line, deal with undefined outside, deal with undefined outside if the pressure is less than or equal to 0. Then shall do that. State 1 outside. What we observed is that the inner door opened, which it really fucking shouldn't. So I guess the next step for us is first to remove, that's very important when you program, remove your debug code, because yeah, that's something that happens in production all the time. Accidentally debug code. Nope. Bad. So just write the current state and otherwise do everything as advised. Export, save, place. Nothing is happening. Why not? Alright, man, that took way longer. I probably cut something out for the first time ever of this video because I did so many stupid mistakes and I don't even know exactly what the problem was. So I made myself a reset chip here and spray painted it yellow, which will just reset the doors to normal instead of logic state and will turn on that thing, so you know, whatever. So let's put the chip in as it is right now. This is my AIRLOCK code. It's not yet completely done. I'm still in the middle. Now I push this button, and actually we can use the device configuration cartridge to see. You can see here the open value is 1 and the setting value is 1. The setting value is the one that will now be switched to 0 when I push, and I think that was basically the key problem that I had when I was debugging for over an hour. Damn it. I was misestimating how the door really functions. The setting value is probably irrelevant to the doors normally, but in logic mode it is relevant, and the setting value will just not change. When the door is open and I push the button in logic mode, then the setting will flip to 0 and will stay at 0. But if I now reset the door to not logic mode and open and close the door a few times, this will not affect the setting value at all. And so now what I do is, I will show you, I will just initialize the setting value to. Okay, anyway, let's push the button. Let's wide angle this. Yeah, maybe that helps. Okay, the door, this is now as intended. I would push one of the two buttons. Actually, one of the two? I haven't yet tested what happens when I push that one. My reset chip. I will do that in the future. It's so convenient. What happens if I push the other button? The same. So, there was some stupid blunder in there, like in all my videos. I fucking hate that, and now that problem has been solved. Now the next problem cometh. It is my annoying reminder program. 1 second, please. Alright, back in business. Now let's look at the source code as it is. And, you know, from the top, because I'm really not sure where we were last, when I cut this. The first time we will cut the online YouTube cut feature. I wonder how that works. I think it's a soft cut that actually doesn't change the file. Instead it will just realize, oh, there is some skip ahead, like 1 hour, 5 minutes, 3 seconds. So I will pre-cache that part, and then when I reach that during my playback, play the cache and move on. No problem. Damn it! Something is always wrong. Okay, the program. First we define the values for the glass door type and for the respective specific outer and inner door correctly, don't swap them. And for the gas sensor and for the vent. Then we prepare some keywords that represent registers into which we can write values. The current state of my state machine here will be this one, the pressure of the gas sensor here, and whether the button was pushed here. Then we will also define our states, and regarding the state undefined, I did a little change down here. Here we have first check if undefined, then go to undefined, and then down here I had the jump to start, but it's actually more wise to just jump to undefined all the time, except if we have a defined state, which means that basically I could skip this one here. So the various states that we can be in our little state machine. Then I set both doors to logic mode, and then I write the current state that we're in, which is of course undefined at the start when we put the chip in, to the housing, so we can just point there and read it in the tooltip, and then I read in a complicated, but that's kind of a way it has to be done, I think, way the button, whether the button has been pushed. Again, how that works, let's ignore this block because it's identical to that block. First I initialize my register with 0, like the button has not been pushed. Then I load from the door the setting. The setting changes when I push the button, like I explained, and then I load also open. And then I subtract the two from each other, and if they're different, then this means I am desiring a different state than the door has. Which means that if the value is 0 equal to 0, then I just skip here. But if it's not equal to 0, as in the values are different, then I will just explicitly say the button was pushed. And here the same for the other door. And here I load the gas pressure, and that always worked fine. And then here, if the state is undefined, which it is at the beginning, let's see what happens, because that has changed. If the pressure is less than or equal to 0, then we are in the outside situation, so we go here. What I do is, I open the outer door, and I close the inner door, you know, open 1, open 0. And I also set the setting so that it's initially identical, so I can properly react to the buttons. Then I set the next state is we are now in a defined state, and that is we are on the outside. And here the same thing in opposite for the inside. Now the state machine continues up here and then checks this state outside. Now we want to wait for the button. Here we are on the outside and check for the button. If the button was pushed is equal to 0, then we just jump back to the start. So we keep checking, we keep seeing the state. Damn it. We keep seeing the state outside, so we keep jumping down here, and we keep seeing the button was not pushed, so we just return up there. But if the button was pushed, then we close the outer door and we move on to the next machine state. And we jump back up here. The next machine state is wait outer closed, because we don't want to open the inner door before the outer one has really been closed. So that's what we do here. Outside wait closed. I load from the outer door the value idle, and if the value is not 1, which 1 is the logical true, yes, if it's not 1, then just jump to start. So boom, 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 we come here again and again and again until the door is done, and then we can open the inner door, and then we can say we are on the inside. So half of our airlock is done. But now, and the hard part has been done, because setting all this up from the start, that's the hard part. Now we basically just have to replicate concepts. We are now on the inside. What shall happen? Well, let's see when we are on the inside. Branch equals state 3. If we are on the inside, then we are in the situation that we are inside check button. So we can basically copy that. Sadly, I cannot copy multiple lines, so I will have to do that on foot. And have to change stuff, of course. First, let's copy the state that we need next, which is the wait for vacuum. Outside check button, outside wait closed, and now inside check button. That was correct. And then we would go here, but let's see what happens. If the button is not pushed, jump back to start. If the button is pushed, then what do we want to do? Do we want to close the inner door? Yes, we want to close the inner door. What we also want to do is we want to turn the vent on. So let's say write to device, badge named CLS vent ins vent mode 1, which sucks from the room. Mode 0 is the default, which blows into the room. That is, less harmful for your health. That is a way to remember that easily. The 0 is always a default value. That makes sense, right? Why would it start when you install it with the value 1? And the mode 0 means harmless. Mode 1 means dangerous. And 1 is when the air is being sucked from your lungs. So we set the mode to sucking and we turn the device on. And then we set the state wait for vacuum, and then we jump to start. Let's save that and write the next state. Pause. Branch if equal. State register. Inside wait vacuum. That's kind of what it is. Inside wait. I mean, we could just say wait vacuum, but if this would be a two-sided airlock, that would be ambiguous, because there would be two different kinds of waiting for vacuum. However we implement that is, of course, open. There are many ways to implement this, but I think this is rather clean how that works. Inside wait vacuum. So what we do here is we can copy the line from down here, where we are checking in the undefined situation what's really going on. Since we already know the pressure, we can do this. We can say branch if greater than GT greater than, if pressure is greater than 0, then we jump back to start, because that is how we wait. That is how the state machine keeps waiting in this state. Wait for vacuum, blah, 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 blah. And then in the end we have to move on to the next state, which is state outside, of course. Where is it? So if the pressure is greater than 0, we jump to start. But if it's not greater than 0, then we can say move to state, the state outside, but I also want to open the outer door, write to batch device named, class door, class ins door outer outer open 1. And I think this is already the entire airlock code. Confirm. Save. Overwrite chip content. Run.
Oxygen low. Oxygen critical.
That is unfortunate. What's going on? Oh yeah, my waste tank. Oh, that's good, because I lost some atmosphere. Okay, why did the airlock not flip to the output side, which we had in the beginning? Because it detected by itself, at least I hope that's the reason, it detected by itself that we have some pressure here, and so the initial state is no longer undefined. Now we know, we're on the inside. Now let's push any of these buttons, for example, there's one. Okay, this door opened a bit fast for my taste. I don't know if that was... if we lost some atmosphere. I'm not gonna go by the numbers, instead I'm gonna introduce some trick, I guess. Oh wait, that needs to turn off. Yeah, of course. I forgot that. Just keeps running. And then I can go to the inside. Oh, right. No worries, it blows into the room, so nothing's lost. Man, when will this have calmed down? I guess that's what it is. I guess it's really that fast. But it seemed a bit too fast. But you know what? There's a trick to find out. Yeah, a good trick. Haha. Because instead of turning on the thing, the vent, I will not turn on the vent, and then it will just wait indefinitely for the vacuum. I will just do that manually, so I can decide when the fuck that happens. So we can see if the state machine's logic is working correctly. So, right, we have to export that first. Export. Aha, see what just happened? I closed the door, but it couldn't yet open the inner door, and then I ripped out the chip. So when I put in the chip, both doors were closed. This thing didn't know what the fuck situation is. Measured, there's no gas pressure in here. So, well, then we must be on the outside. And so it opened the door and reproduced this state. That's a nice airlock. So let's see what happens if I actually want to go outside. Ah. It's really that fast. What the fuck? Okay, but we want to turn that off, and so I guess we should add another state where we wait for the... do we? No. No, once we have vacuum, we decide to open the outer door, yes, and change the state. We should also decide to turn that thing off, that is all. And then the airlock is done. Move state 1 outside. Outer door open, vent off. Confirm. Export. Run. Put away laptop, proudly, because we're done. Preemptive, probably too early, something will probably be changed. So, I'm doing stuff. Fast, huh? I get the feeling that moving indoors is even slower than moving outdoors with the active vent, but that's bullshit. So fast. No, there's some pause in there, isn't there? Close. Open. Close. Oh no, it's the same. Nice. A nice, fast, automatic airlock, custom programmed. I think I will actually put that source code into some kind of paste bin kind of stuff. Probably not in the description. Sorry. Man, this is fun. Yeah, let's try some edge cases. What if I am a bit too forward with my pushing here? What am I too pushy, huh? What might happen is that the airlock cycles to the outside already while the indoor is still closing, or I don't know, whatever the fuck. Anyway, it's working nicely. Oh, I'm locked out. Not a problem. It listens to both buttons. Yeah, okay, let's take a look at the source code again one last time, and then I guess that's the end of this video. So, from the top. I want to operate machines. In the game, the machines have numbers. They are referenced by numbers. Not just the individual machine is referenced by a number, but also the type of the machine. And even the names of the machine. You know, I mean, if I make up a word that exists in the world, like I name a door, henceforth that name exists and will then also have been assigned a number. And if I rename something else to that same name, that will then probably also just be the same number. Makes sense. Okay, here I go and say, give me the number of the type glass door, and give me the number of the of this name outer, and give me the number of this name inner. And down here, I'm operating the doors. Somewhere I have, you know, a load and save L and S are being used, and SBN means save batch named, save into all doors that have this, that are into all devices that are of this type and have this name, and in them address the parameter open and write 0, which means that in practice just the outer door here closes. That's what this does. Then the gas sensor and the vent. Then we have some registers defined so that we don't have to write R15 down there, but instead something that speaks to us. Then we have the states of the airlock. See, state machine, important concept, if that's even the correct term, state machine. And at the beginning we also have an explicitly undefined state. I think it would have the value 0 from the start, but you know, let's not make assumptions. Let's create a defined value, defined situation. And then I also set both doors to mode 1, which is logic mode, so I can no longer operate them. They can only interact, you know, with source code. Then here we have our start, and down here basically we have our jump start again, except I'm taking a detour down here to deal with undefined. Maybe I should make it more clear and say jump start, so that it is clear why this is so. So this is our main loop. Confirm, save, edit. And in this main loop, what we are doing is we are first writing the current state of our state machine to the housing, so we can see what's going on. Then we fiddle with the door buttons. We try to find out if one of them was pushed, and henceforth in this value, which is just a register, but we don't need to know that, is a 0 if the button was not pushed and a 1 if the button was pushed. And we also have the value of the gas sensor here in the value press. And then we evaluate what situation we're in. If we are in this or that or whatever state, but when we start up, we don't have a defined state yet. We explicitly have that state or whatever state we might have. And so the program says, deal with undefined. In the situation undefined, we look at the gas pressure, and if the pressure is less than or equal to 0, less than, lol, this is what we are on the outside. Then I explicitly open the outer door and also reset the setting, you know, the button push thingy, to 1. So we have a clear, crystal clear defined state, and the inner door closed. And also I maybe I should also turn off the vent. That would make sense. SBN CLS vent ins vent on 0. Because, you know, undefined state, we ripped out the chip while the thing was pumping. I want to be able to just throw the chip in again, and then everything should be in a sane situation as consequence, and that is what this should do. So if we outside, open the outer door, close the inner door, and then now we are in a defined state, the state outside. If there was gas pressure, then the same thing happens for the other way around, the other door, and then the state is state inside. So when I plug in the chip, it will always know what to do. Now we return up here to the state machine main loop, where we then see the state is outside. What do we do in the situation that we are outside, or in the situation inside? We check for the button, because only then we're interested in that. In this AIRLOCK. You can program an AIRLOCK any way you want, but this is the simple one that we made. It's very fast. Okay. Here we wait. We see if the button was pushed. If not, we just return up to start, to the main loop start, where it will then check for the same state and will arrive down here again. So it checks this again and again. But if the button was pushed, then it will say outer door close, open is 0, and the next state of the machine will be used henceforth, which is wait for the outer door to have been closed. Yeah, and that is here. Then we jump down to the respective part of the source code. Outside wait closed. We load from the outer door whether it is idle. If the value idle is not equal to 1, then up there, back to the main loop, nim 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 nim. Eventually it will be 1, and then we open the inner door and set the state to we are on the inside. The same state that we had down here. Basically could be a start state, initial state. It's not an intermediary state. Then here on the inside we check for the button, so that's like the mirror partner of that. If the button was not pushed, that go back to start. If the button was pushed, now things get a bit more complicated. We close the inner door and we start the vent to pump out the air here, which will probably also suck in a little bit of air from the inside the room, but it is so fast that I don't care to add another state for this machine. Just suck it immediately. And set the vent to sucking and turn it on, and then wait for vacuum. So we're here in the wait for vacuum thing, and then we go here, the next state. If the pressure is greater than 0, then we're still waiting for vacuum. But if we are at pressure 0, then we want to turn off the vent, and we want to open the outer door, and then we are in a state outside. And that is the entire AIRLOCK. Confirm, export, run, and actually let's use the reset chip. And now I will actually open my waste tank. Now the pressure in here is 4 kilopascals, which is very low, but that very low is not 0. So if I put now the chip in, it should think, oh, we are on the inside. Okay. So this is kind of a dangerous thing to do if you have your arc furnace right in front of the door and is smelting some iron, excreting some pollution, for which you should then have actually an advanced AIRLOCK, which has 2 pumps, basically 2 directions in which you pump. Anyway, then it will think, oh, we're on the inside, but the truth is not. We're not. We're on the outside, and I would rather have, would rather keep it that way. But, edge cases and all that. But we have a nice, very fast AIRLOCK, and it's completely custom made. Dude, man, it is fast. It is so fast even that I should consider, should I extend this video a little, pushing the buttons automatically when I enter this room. Wouldn't that be cool? I walk in here, the AIRLOCK toggles. I walk in here again, the AIRLOCK toggles. Should we try that? Yep, we shall try that. Let's do that. A bonus round. Yeah. So, am I still recording? Yeah. Sometimes I might be on pause and not realize it. That is sucky, but no, has never happened. What is that? Sensor. Yeah, the kit sensors, which has stuff that we can use here. Thank you very much. So we need to add another sensor to this, and that would be the... Actually, it's read up on the occupancy sensor. Occupancy sensor. Will be triggered if there is a player in the same room as the sensor. Room. That is interesting because the rooms can also be larger. I think it did explicitly not say cell or whatever, room, world cell, but room. I mean, it doesn't make a difference. In this case, it's identical because this room has an identity. 11. 5. 11. World. 11. So we can use the occupancy sensor. As soon as someone is in here, who might that be? It is me. It should be toggling. So we have to wire that up. If there's some room here, somewhere. Occupancy sensor. Ah. Ah, that should work. Occupancy sensor. Ah, look at that. It even indicates whether it's occupied or whether there's occupancy. Now that helps with debugging. So let's wire this up. And if we would only toggle the airlock using the occupancy sensor, then we would be in deep shit sometimes, because maybe the airlock was toggled. We're on the outside pushing the button desperately. The occupancy sensor is like, no, you're not inside. What's happening? Why is it not a number? I assume this is a quirk with the implementation of the consoles, which are slightly buggy. So maybe all I have to do is turn on and off again? That would be hilarious. Oh yeah, that was indeed what it is. You know, the thing was a bit more confused. Where's... yeah. Occupancy sensor obviously connected. We got some strong indication here. Now let's give that thing a name. Copy this. And this is also a sensor. I didn't expect to have another one. Occu. Let's use that. And guess what? This is probably structure occupancy sensor. Structure occupancy sensor. Yeah, fuck those numbers. Laptop. Up. Edit. Pause. Zip. First check how big the source code is. Oh my god. I would have run into just that problem just now. Good thing I thought of this. Because if I insert some lines up there, the lines down here will not just move past the end. They will be deleted. That's quite annoying. So let's just delete this crap here. So basically we want to find out if the button has been pushed. Though that would be a bit kind of a special thing. We can't just copy the state of the occupancy sensor to whether the button has been pushed, because then we stand in here and the airlock keeps toggling. So we need to use some kind of trick. I don't know what yet, but let's see. Hash define ins occu. Yeah, that was actually wrong. I needed structure occupancy sensor. Okay, now we can read the state of that sensor. First check. Zip. Oh, looks good. Load badge named. Into register R0. Ins occu. What do we want? Occupancy? No. Occupied. Is it occupied? Yeah. And then we say SDB setting R0. Jump start. I want to see what happens. Save game. Export. Check out the housing. Status 1. Huh. Status still 1. Okay, let's see what values we have here. Quantity. Oh! Yeah, I have to read the amount of people who are in the room. That is what that is. Cool. So instead we use quantity. Confirm. Export. 1 0 0 0 0 0 0 0 1 0 0 0. Okay, now we can see that. Alright, let's remove the debug code, which is... ah yeah, right. Have another register for that, ALIAS occu. occupied. Now let's use occu because occupied is a keyword, and I don't know if that is harmless to use as a register name. It will be colored, even though it shouldn't have been in that context. But you know, occu R12, 15, 14, 13, 12. And into that then we load this value and move it to where we also have the gas sensor reading, because that is a nice organized way then. Check if some source code was lost. No. Is there still a jump start? Yes. Confirm, save, edit. So now we use that value somehow. Let's just see what happens if I just copy that value into... Where is it? Where is the button stuffs? Button, here we go. So, B LT, if less than or equal, occupancy 0, less than or equal to 0, then, oh, right, relative to. Because the very next line will do this. And then we have our automatic airlock, except it's still a bit crappy. How did I just put that in my pocket while typing source code? But it should, yeah, it works. So, in there. Up. Apparently I did something wrong. At least it's harmless-ish. But I put the reset one in. Probably some race condition, you know, it was already in the process of closing and didn't accept the new command meanwhile. So, what is my mistake? Branch, if less than, I should have used LE, less than or equal. Yeah. Yeah, stupid mistake, but these are easy to catch. I hope that I can cut out this complete hour of wasted idiot time, because that was not entertaining. Ah, nothing's happening, except it is. I didn't push the button. Now the arrow keeps cycling. Yeah, it measured that I was still occupying it, so it's toggled it again. So we have to make sure that this does not happen. Actually, are we losing atmosphere? That's the fastest way to find out. Oh, actually we are losing atmosphere, you can see that here. So, is the airlock perfect? No, it's not. But it usually will not be toggled this fast. You know, that was the problem. I keep clicking now. Oh, no? No, we're not losing atmosphere. That is just, yeah, that's something I actually don't like. These, you know, Rocketworks made the animation of the moving air gas in a way that kind of overreaches. It moves past the place in which you are, probably because it moves in all places in this room somewhere, and so necessarily it moves to somewhere else. Maybe that's the reason, but no, they need to at some point change that, because it expresses something that is not actually happening. Therefore it shouldn't express that then. Now, what can we do to make sure that the occupancy sensor is ignored? We will constantly have the knowledge of the occupancy. Basically what we want is, has the airlock been empty? Only then reconsider the occupancy. That's what we need. So, yeah. So let's have another variable here. ALIAS non-occu R11. And initialize that, because it's kind of important to initialize. Move non-occu 0. We use 0 and 1 as true and false statements. Was it non-occupied? No. So, next time you want to react to the occupancy situation. Here the occupancy will be red, but we can actually just tamper with that value up here, so we don't have to consider... Wait. What? I'm even loading the occupancy below checking whether we are occupied. That is dumb. That is quite unclean. So let's just frame this code like this, okay. So if the occupancy is less than or equal to 0, we skip this, otherwise we pretend that the button was pushed. But over up here, we will fuck with the occupancy. We will actually say down here, we will skip 2 lines. 3 means 1, 2, 3. It jumped here, now it jumps here. And why does it do that? Because move non-occu 0. And actually up here we have to say non-occu. Wait, non-occu 0. Non-occu 0 because it has not been non-occupied. No, here it realizes we're occupied, and then it says, okay, next time I only want to react to that if we had a non-occu. So non-occupied is 0, and button was pushed is 1, and then we just move on with this empty line and so forth. You know, 3, 1, 2, 3. Could also use a label here, but whatever. 2 lines, that still works. And so I initialize with non-occu 0. That's stupid. Non-occu is 1, because it has been non-occupied. And so we can just run with it. So here we load the value occu, and if the value is 0, then we want to reset non-occupied to 1. Down here is set to 0, and up here it's set to 1. So when do we want to do that? If we only want to do that if there's actually no occupancy. So branch if greater than occu 0, branch relative 2. So if there is someone in here greater than 0, we skip this line. If not, then we have a non-occupancy that we can denote. But now we have to do the following. If it is still marked as occupied, bgt non-occu 1. 1 second. Okay. Here we load whether the slot is occupied, whether I'm in the room. If there is someone here, then we just skip the next line. Otherwise, we write down that we explicitly saw that no one was in here, non-occupied. And then we move on here to this line. In any case, this line will be executed. And here we check if non-occupied is greater than 0. If non-occupied is greater than 0, then we have explicitly the non-occupation situation, with which we also initialize up here, and that we set to 0 down here once we have reacted to the occupation. But if non-occupied is not greater than 0, if it is 0, like it was not reset by someone not having been here, then we delete the occupancy even though someone's in there. That should solve the problem. Where's the chip? Export, put it in. Now we should toggle the AIRLOCK by that action. We don't. I don't know what that was, but okay. Okay, that is an automatic AIRLOCK if I've ever seen one, and a fast one too. Bop de bop, boop de boop, diddly dop. Do the buttons still work? Yeah, they work. Yeah, perfect. Okay, that's the end of the video. I will hopefully put up a link of the code. Okay, it's sometimes undesired. I could add a lever up there, out there, which turns off the automatism if I sometimes desire it, but you know, not for now. Since we're ending the video, maybe we could just explode some stuff, you know? Do I have something to explode? Let's destroy the base for goodbye. Do we have some explosive stuff? Not quite. I should have something for smelting. Ah, yes. What's in there? Glorious. And what's in here? Gloriosa. Do I have my welder with me? Is it still the classic one that has a flame? Yes. See, the classic one is not so good as the as the new one, as the arc welder, but it has the upside that you can generate fire whenever you fucking need it. And now we need fire, baby. Lots of it. If you look at the right bottom, and I'm busy doing other stuff, you can see that the pressure is increasing, probably unreasonably, because 200 kilopascals will break these walls. You can hear that already. So, time for this then. Good night.
Damage. Temperature critical.
Yeah, that's more like it.
Toxin detected. Toxin critical. Oxygen low. Oxygen critical. Toxin critical. High pressure. Toxin critical. Toxin critical. Toxin critical. Waste tank caution.
Die already!